Alright, this is our video for section 3.5, and it's on solving systems of equations with three variables. The first thing we're going to do is talk about the types of answers we could have. If an equation has three variables, then it's going to be graphed on a plane. We're graphing it in the three dimensions. We've got an x, a y, and a z, and we've already learned how to do that. You've watched your video on that. So we're going to go ahead and talk about the types of answers here. The first type of answer you could have is a point, which we know as an ordered triple. Okay, our three planes would all intersect, and they would intersect at a point, and then we would write that x, y, z as an ordered triple. Second type is that those planes, all three planes, could intersect at a line, and then you would have an equation for an answer. And the third type is that the planes don't intersect at all. You would have three parallel planes. And this is an example of a no solution type of problem. The one that we're going to focus on in the video is this first one. The answers is a point, but you need to know that you could have all three of those as answers to your problems. Okay, there are 5 steps to solving a system of equations with three variables, and the first one is to combine the three equations into two variable equations. So somehow we're going to get rid of one of our variables into two equations with two variables. And you're going to use either substitution or elimination. You have to use one or the other to get that. So again, the first step is to combine the three equations into two equations using two variables, using either substitution or elimination. Step 2 is to solve the new system of equations, solve the two variable system of equations, which we've already done. Okay, we learned 3 ways to do that. We graphed, we used substitution, or we used elimination. So you guys should be good at this step, at step number 2. Step 3 is to take your answer and plug it in, because at this point, after step 2, you will have one variable equaling a number. You're going to take that answer and plug it in to a two variable equation, one or the other. It doesn't matter which one, because you'll get the same answer. And now at this point, you should have two variables that are numbers, whatever two you solved for so far. After step 2, you should have one number for an answer. After step 3, after you plug it back in, you should have 2. Step 4, you're going to plug in numbers again. You're going to choose one of the three variable equations. And plug in the two variables that you know. Plug in the two variables you know at this point. So at step 4, you should have all three numbers to your problem. Step 5 is to write it as an ordered triple. Okay, and remember that's x, y, and then z, and a set of parentheses, commas between them all, just like you would write an ordered pair. Alright, we're going to do 2 examples. Our first example is a system of 3 equations, 3 variables. 3x plus y minus z equals negative 6. 2x minus y plus 2z equals 8. 4x plus y minus 3z equals negative 21. We're going to go through our steps. Step 1 says to combine the 3 equations into 2 using either substitution or elimination. I'm going to go ahead and use elimination because for most people that is the easiest one to use. So I'm going to look here and see which variable I want to eliminate. Well, this problem's already set up so that the y's should eliminate nicely because one's negative and 2 of them are positive, and they all have the same coefficient out in front. So what I'm going to do is I'm going to pair them up. I'm going to pair the first two. So I have 3x plus y minus z equals negative 6. 2x minus y plus 2z equals 8. And I'm going to use elimination. The y's are going to cancel. Remember, we add down. So I get 5x. The y's are gone. Negative z plus 2z is just plus z equals negative 6 plus 8 is 2. Okay, that's going to be important. That is one of our two variable equations because we've canceled out the y's. Now I'm going to take the other two. I'm going to do the same thing. I'm going to pair them up. 2x minus y plus 2z equals 8. 4x plus y minus 3z equals negative 21. Let's use elimination. Again, the y's are going to cancel. That's the variable I want to get rid of. So 6x, y's canceled. 2z minus 3z is minus z equals, and 8 minus 21 is a negative 13. Now, something you want to remember is that when you're using elimination on these or substitution, you want to get rid of the same variable in both sets. I don't want to solve the first one and have an x and a y and then get to my second problem and have a y and a z. That's not going to work. I have to get it down to two variables that are the same variable in both equations, which is what I've done. So now I've got a two-variable system, 5x plus z equals 2, 6x minus z equals negative 13. And I need to solve this now. This is my two-variable system of equations. So at this point, we're at step number 2, and we're going to solve the two-variable system. Well, let's set up nicely for elimination, because one z is positive, one z is negative. They'll cancel. So we're going to add down again. 5x plus 6x is 11x. Z's canceled. 2 plus the negative 13 is negative 11. Divide both sides by 11. X equals negative 1. There's one of the numbers for our ordered triple. We know what x is. Step 3 says to plug the answer I got into one of the two variables equations, and then I should have two variables after that. So we're at step 3 now. It doesn't matter which one I plug it into, I'll get the same answer. I'm going to plug it into the top one, which is 5x plus z equals 2. So now it's 5 times negative 1 plus z equals 2, because we've got negative 1 to be x, minus 5 plus z equals 2. Add 5 to both sides, z equals 7. So there's my second number. At this point now, I've got two of my three variables. The last thing I need to do, I guess the second to last because we still have to write our answer, is that we're going to choose one of our three variable equations at the top here, one of the original three, and we're going to plug in our value for x and our value for y, our value for z, and we're going to solve for y. I'm just going to plug it into the top one. You could plug it into any of the three, it doesn't matter. So it's going to become 3 times negative 1 plus y minus 7 equals negative 6. 3 times negative 1 is negative 3, plus y minus 7 equals negative 6. Negative 3 minus 7 is really negative 10, so it's y minus 10 equals negative 6. Add 10 to both sides. Y equals 4. Well, now we've got all three of our numbers, so we've got to write our answer as an ordered triple. It's x, y, z. The x is negative 1. Our y we got to be 4. And our z we got to be 7. So here's the answer to our problem. Negative 1, 4, 7. Okay, let's look at example 2. Example 2 is negative 4x plus 4y minus 2z equals negative 8. That's our first equation. Second equation, negative 3x minus y plus 4z equals 0. And the third equation is 2x minus 2y plus 3z equals negative 4. Now we're going to do the same thing here. We got to get these three equations down to two equations with two variables. So we're going to have to get rid of something. I'm going to use elimination again because that's the one that's the easiest for me, but you could use substitution if you wanted. Now this one's a little different because one of those variables isn't set up to eliminate itself right off the bat. So we got to pick a variable to eliminate and multiply through our equations by numbers so that they have the same variable that will all cancel, and then the coefficient of two of them is the same And then the third one is negative, or positive is the opposite, so that when we combine them using elimination, it'll cancel itself out. I'm going to cancel the y's, because that's the easiest one for me. You could cancel whatever you wanted, though. You could cancel the x's, you could cancel the z's, you just multiply through by different numbers. So I want to cancel the y's here. I want the top one to be positive, the middle one to be negative, and the bottom one to be positive for the y's. So they all have to have the same coefficient. They all need a coefficient of 4, but the middle one I want to be negative 4, so that when I combine them, the first two, the second two, it'll cancel out when I use elimination. So for the top one, I don't need to multiply by anything because it's already 4y. So I'm going to put a 1 out in front so that I know I don't have to multiply through by anything, because multiplying through by 1 is not going to change anything. The second one, it's negative y. I want it to be negative, so I'm just going to multiply through by a 4. And then for the third one, it's a negative 2. I want it to become a positive 4, so I have to multiply everything through by negative 2. And again, there's different ways to approach this problem. So if you're using different numbers when you work it out in class or on your worksheet, that's fine. There's many different ways to do it. So let's multiply through. The first one's not going to change because, again, anything times 1 is going to stay the same. So negative 4x plus 4y minus 2z equals negative 8. The second one, I have to take that 4 and it gets multiplied to everything on both sides of the equations. Well, 4 times negative 3x is going to become negative 12x. 4 times negative y is negative 4y. 4 times 4z is going to be positive 16z. Then on the other side of the equation, 4 times 0, make sure you multiply that, is going to be 0. Anything times 0 stays 0. Look at the last one. We've got to use the same idea we did on the second. That negative 2 gets multiplied to everything on both sides. Negative 2 times 2x is going to become negative 4x. Negative 2 times negative 2y is positive 4y. Negative 2 times 3z is going to become negative 6z. And negative 2 times negative 4, don't forget the other side of the equal sign, is going to become positive 8. Now I'm going to pair them up. First two. Let's add down. We're going to use elimination because that's what we decided. 4x plus 4y minus 2z equals negative 8. It's the first one. Negative 12x minus 4y plus 16z equals 0. Add down. Negative 4x minus 12x is negative 16x. My y's canceled. That's what I wanted to see. Plus negative 2z plus 16z is going to be 14z equals negative 8. Let's look at the second two. Negative 12x minus 4y plus 16z equals 0, and negative 4x plus 4y minus 6z equals 8. We're going to add down. Negative 12x minus 4x, well, that's negative 16x. Y's canceled again. That's good because both of our two variable equations need to have the same numbers. 16z minus 6z is going to be 10z, and 0 plus 8 is 8. So here's our two equations now. We've got negative 16x plus 14z equals negative 8, and negative 16x plus 10z equals positive 8. Now I'm going to use elimination again. I want one of those variables to cancel. Well, the 16s are pretty close, except they're both negative, and I need one to be positive. So I'm going to multiply everything in the second one by negative 1. So it would become negative 16x. The top one's going to stay the same. Negative 16x plus 14z equals negative 8. Remember that negative 1 goes to everything, so it's going to become positive 16x minus 10z equals negative 8. We're using elimination, so we add down. X is canceled. 14z minus 10z is 4z equals negative 8 plus negative 8 is negative 16. Divide both sides by 4. Z is negative 4. There's one of our answers. That's the first one of our variables. Now we're going to take that z, plug it back into one of our two variable system of equations. Doesn't matter which one, I'm going to get the same answer either way. I'm just going to plug it into the top one. Negative 16x plus 14z equals negative 8. It's going to become now negative 16x plus 14 times negative 4 equals negative 8.
negative 16x minus 14 times negative 4 is going to become negative 56 equals negative 8. Add that 56 to both sides. Negative 16x equals positive 48. Divide both sides by negative 16. So x equals negative 3. There's the second variable. The last thing we have to do is go back to one of the original problems, the original equations, and we're going to plug in our x and our z, and we're going to find y. We're going to just plug it into the first one. Doesn't matter which one you plug it into, you will get the same answer either way. So negative 4x plus 4y minus 2z equals negative 8. It's going to become negative 4x times, not negative 4x, negative 4 times negative 3 because x is negative 3 now, plus 4y minus 2 times negative 4 equals negative 8. Negative 4 times negative 3 is 12, plus 4y. Negative 2 times negative 4 is positive 8, equals negative 8. Let's combine what we know here. We get 20 plus 4y equals negative 8. Subtract 20 from both sides. So 4y equals negative 28. Divide both sides by 4. Y is negative 7 because negative 28 divided by 4 is negative 7. So we got our three variables. We need to write them as an ordered triple. Negative 3, negative 7, negative 4. Make sure you have them in the right order. X, Y, and then Z. And there's the answer to our problem. Negative 3, negative 7, negative 4.